All right, hi Aaron. Sorry you're missing our class. We're taking a little turn from these trig problems, and I will include 3 from the past lessons on today's lesson, but we're going to take a turn and just go into the algebra and leave the trig behind. What do you say? All right, you don't look all that excited, but we're going to do it anyway. Were you wondering how to integrate something like this? Get ready to write it on down. Jonathan, get ready to write this down. Were you wondering how to integrate something like this?
Yes.
I know. This whole chapter is just integrating stuff that we couldn't integrate previously. So we're gonna, at the end of this few minutes, you're gonna be able to integrate that. All right, we're gonna use a method called partial fractions. All right, to integrate this is only going to be doable. We can only use this method if the denominator, not the numerator, the denominator, do you hear me now? The denominator is factorable. So is this qualify? All right, Morgan, if you would factor it.
X minus 3, x minus 2.
All right, that's correct. So what we're going to do is decompose that fraction once it's factored on the bottom, and if it's not factorable, you'll have to find another method. I want you to decompose it. It sounds a very dreary thing to do. We're all going to decompose at some point, but I wasn't thinking we would start today. But we are going to decompose this fraction. To decompose a fraction, we're just going to go over to algebra land for a minute, then I'll come back and take the integral. Actually, I teach this, some years, I teach this in pre-calc. So you should, come here knowing this. So I'm just taking the fraction out of this problem, I'm going to decompose it over here, and when it's all decomposed and nice and stinky, we'll bring it back here because we'll be able to integrate it. What I try to do when I do teach this in pre-calc, I don't think that I knew it would show up. All right, well we have a spare. In pre-calc, when I teach this, I like why do you have to take a fraction and range it all around and say, oh, this is decomposed? And really, you don't really know that until this day in calculus. So when I'm teaching that in pre-calc, I like to go and grab a calculus student and bring them in front of everybody, unrehearsed. So they just come in, and I say, can you integrate that? And they go, no. And then at the end, there's this nice decomposed fraction, can you integrate that? And they go, and it impresses everybody. So, all right, so I didn't teach it for some reason in your year. I don't know what happened, but you didn't get that glorious lesson. So I have to teach it to you now. So to decompose a fraction, you are going to write it in a new form. The form looks like this. A, which you're going to solve for in a minute, with good old algebra, over the first factor in the denominator, plus b over the next factor, and that'll continue if there's more factors than that in the denominator with a c and a d and so on. This one only has 2 factors. So that's how you set it up. So can you write that down as well, Jonathan? We're going to write one factor under a and another factor under b. This is called decomposition. And when we finish decomposing this fraction, it'll be integratable. All right, now we just use good old algebra to do that. I'm going to multiply through, I don't like denominators that much. So I'm going to multiply through by that common denominator. So I'm going to multiply this fraction, and that fraction. All right, Brendan, start doing that for me. When I multiply this times this, what do I get?
1 1.
And this times that.
X minus 2 times A.
And then this times that.
B times X minus 3.
All right. Any questions on where that came from? We're just clearing the denominators by multiplying through by the least common denominator. Now, when these factors are linear, that means this is degree 1 and this is degree 1. The easiest way to solve that is this. And I'll show you a way when that gets too messy. We have another way, but that won't be today, I don't think. So we'll just use, when these are linear, or yeah, I think that when these are linear, we can use this method every time. So I'm going to let x equal a value. Because x, we do that all the time. Say y equals 2x. Well, what happens to y when x is 3, when x is 400, when x is minus 2? So we can let x equal whatever we want. So I am going to pick an x that will make this fall quickly into our lap. I'm going to say let x, keeping my eye on this, let x equal 2. Because then this term will zero out and we'll get somewhere. So I'm going to say let x equals 2. When I do that, Gianni, give me this whole statement filling in a 2 wherever there's an x.
So 1 equals A times 2 minus 2 is 0.
Right, so that term zeroes out. And what will this one become?
That'll become minus B.
Right, so minus b, because the 2 minus 3 becomes a minus 1. So I have 1 equals minus b, so b must equal minus 1. So that's what we're trying to do below this statement is find a and b. All right, so now that we have b, I can come up and put that in up here, or you can rewrite it. A minus 1 goes there. All right. What do you think, Morgan? I might let x equal this time to further our study. Keeping your eye on this
three,
prize.
Yeah, I was gonna say 3. Maybe 3.
Yes. So let x equal 3. So Morgan, go ahead and do that then. Give me this expression with x equals 3.
So that'll be 1 equals A minus 0. So
All right.
it's A.
1 equals a. So do you see how quickly these can fall into your lap? So that means now I can go back to the original way up at the top, and instead of an a, I can put a 1 here. Instead of a b, I can put a minus 1 here. Or perhaps you prefer minus there, but it doesn't really matter. So, class, this is my moment of triumph. Is this something you can integrate? No. Is this something you can integrate? Yes. So, would you integrate that, Jonathan? I want you to integrate 1 over x minus 3 and negative 1 over x minus 2. So what will the integral be? I'll write it over here while you ponder. What is the integral of 1 over x minus 3?
ln x minus 3.
Very good. And integral here. Also.
Negative ln x minus 2.
Right.
Okay.
Sometimes when you look in the back, x minus 2. And sometimes when you look in the back of your book, they will have used log rules to simplify that. So let me show you what this looks like using log rules, just in case you look back there. I'm not requiring you to use them to simplify your answer, but remember when you took one log and subtracted another log, one log subtracting a second log is like taking one log and dividing the arguments. So you might see something like that in the back of the book, so just kind of undo the log rules and you'll see if your answer was correct. Sometimes they use them and then the next problem they don't, so I can't quite figure out the reasoning. How are we doing for time?
We're at 10 right now.
Okay. All right, since we're gonna go into another problem, we'll just close it up. All right.